Hi everyone, in this video we'll look at a review of trigonometric ratios and special triangles. So recall that from previous courses where you were told this acronym, SOHCAHTOA. You were told to memorize this, and you were told that the sine of an angle is equivalent to the opposite, or the sine of an angle in a right angle triangle is equivalent to the opposite side divided by its hypotenuse. So in the triangle that I've drawn here, that would mean that the sine of angle A is equal to little a over c, or a over c. The cosine of angle A is equivalent to the adjacent divided by the hypotenuse, which is b over c. And the tangent of angle A is equal to the opposite divided by the hypotenuse, so a over c. Now, recall that that also in when we label triangles, that we use capital letters for the angles and we use lowercase letters for the side lengths. We could also calculate the trigonometric ratios for angle B. So we could say that the sine of angle B is equal to b over c. The cosine of angle B is equal to a over c. And the tangent of angle B, the tangent of B is equal to b over c. B over a, the opposite divided by the adjacent. And the opposite side length is b, the adjacent is a. So b over a. So suppose that we are given a triangle. Recall that from grade 10, you could use these trigonometric ratios to either solve for interior angles if you're given two of any side length, or if you're given an angle and a side length. You can also solve for the other angle, but you could also solve for the other side lengths in the triangle. So let's go ahead and we'll look at an example of how to do that. So let's suppose problem 1. So in problem 1, so we'll say given the triangle below, solve for all lengths and angles. And let's label this again. We can just write this as, I'll draw a triangle here, and this will be a quick recap from. So let's suppose this is 4, this is 3, and this is 5. Actually, let's just, okay. Spoiler alert. Let's just do, let's do something different. Let's try 4 and 5. And let's label this as triangle A, B, and C. Okay, so just a recap of how to actually use the triangle, the trigonometric ratios. Let's write down what the trigonometric ratios actually are. And recall that you can only use these SOHCAHTOA for right angle triangles. So please don't try to use this for triangles that are not right angle triangles. It will not work. And if you need more information on these rules, I'll try to post another video at a later date on how the trigonometric ratios relate to similar triangles in right angle triangles. And I'll post a video explaining the trigonometric ratios in more depth later on. So recall that here, let's suppose that we want to figure out what angle A is, and we want to figure out what angle B is. And here we're also asked to figure out what all of the other side lengths are. So first off, we could use the trigonometric ratios to figure out what AB is, or I could just use the Pythagorean theorem, because remember that for right angle triangles, a squared plus b squared is equal to c squared. So c squared here is going to be equal to 4 squared plus 5 squared. And the c squared will be equal to, let's see, 16 plus 25 is 41. C squared is going to be equal to 41. And thus c is equal to the square root of 41. So now that I know this, I can calculate what all of the trigonometric ratios are in this triangle. We have that this side length is root 41. And we know that if we want to figure out what angle A is, we know that now let's use the tangent ratio. We know that the tangent of angle A is equal to the opposite divided by the adjacent. The opposite to angle A is 5, and the adjacent is 4. So we know that the tangent of A, we've calculated we've figured out what this ratio is. It's the opposite divided by the adjacent. Now, if we want to solve for angle A, and we actually want to figure out what the value of angle A is, we can use our calculator, and we can say that the angle A is equivalent to the inverse tan, also known as the arctan, of 5 over 4. You can compute this on your calculator, and remember to make sure that your calculator is in degree mode when you calculate this. But if you say the arctan of 5 divided by 4, you get that this angle rounds to 51.3 degrees. We could use a trigonometric ratio to figure out what angle B is as well, or we know that this angle is 90 degrees, angle A is 51.3 degrees, and we know that all three of these angles have to add to 180. So angle B is equal to 90 degrees minus angle A, which is 51.3 degrees. And so angle B is 38.7 degrees. So now we've solved for all of the angles in this triangle. In the next part of this video, or in the next part of this lesson, we will look at special triangles.